In today's notes, we're going to talk about ellipses. Ellipses are the third type of conic section that we will talk about in the conic sections unit. In the content for ellipses, I want you to keep in mind that the image that it creates as you look below is very similar to a circle in the sense that it has that oval round shape. However, it's more oval than completely round and circular like an actual circle would be. With the equation that you see for this page, I want you to keep in mind that it's a little different than circles in the sense that it has denominators and it no longer has a radius. So let's go ahead and look at the information that's on this first page. An ellipse is the set of all points in a plane such that the sum of the distances to two fixed points called foci is a given constant. I want you to keep in mind with all of this, we've seen this before, and I hope it's kind of making your brain tingle because you should remember that when you see a fixed point like this is called a focus. We talked about this last class period with parabolas. I specifically told you that a fixed point is not on a line, and that is called a focus point. Well, with the focus point on a parabola, let me draw this out. Here's your parabola. Your focus point would be somewhere inside of it. I kept saying it's like giving your parabola a hug. That's what a focus point is doing. Well, the same thing's going to happen for ellipses. The only difference is we're not going to necessarily be like hugging it like we would the parabola. However, it should be in the middle of your graph. So you should see that focus point in the middle of your ellipse every time you graph it. So before we do anything else, I want you to take a second and look at both of the equations I have here and here for your ellipse. Take a second and compare what is similar and what is different. Okay, let's talk about the similarities. In both of these equations, they both have x minus h squared, y minus k squared in the numerator and denominator, or not numerator and denominator, but in the numerators for both. They're also both being added, and they're also both equal to 1. With circles, they were equal to your radius. Well, with an ellipse, you don't really have a radius because as you go from the center out to one of the sides of your the ellipse, not the circle this time, but for the ellipse, it's not going to be the same everywhere you go. So we no longer have a radius for ellipses. Those are all the similarities. What are the differences between these two? Notice that the a squared was first in the first equation, and the b squared was second in the first equation. That's different when you look at the second one. Okay, well, that actually is going to help me with identifying which of these graphs should be horizontal and which of these should be vertical. So I'm going to focus my attention right now on the first graph, which is the standard form horizontal ellipse. Just like a circle, the h and the k value is your center. That's still the same. From there, I want you to identify or notice that the a squared value is underneath the x squared term, the x minus h squared term. When you have an a squared that's under the x squared term, this is actually extremely helpful. That means that your graph is going to be horizontal. So that means this elongated graph that you see that's kind of stretching along the x-axis, that's the graph that you're going to create. So whenever you're looking at multiple choice questions on a test or quiz, if you notice that the x squared term right below it has an a squared, I want you to make sure that you look at all of the graphs that are horizontal, that are elongated along the x-axis. Major and minor axis. Okay, well, the major and minor axis directly relate to the a squared and b squared values. Let's start with the major axis. The major axis goes from here to here, this entire length. The major axis relates specifically to a. So whenever you're trying to find the actual length of that major axis, which is what I highlighted in red earlier, that should be a plus a, which could be rewritten as just 2a. That whole length right here would just be 2 times a. Whatever this a value is, multiply it by 2, and you'll be good. For the minor axis, this directly relates to b. So for this minor axis, which is this whole length here, it's going to relate to your b value. So whatever your b value is, if you were to pretty much just double that, that will give me my minor axis length, that distance. Remember how at the very beginning I said that there were 2 fixed points called foci? Or foci, doesn't matter which way you say it. I usually say foci though. Notice that we only have 1 focus point right here. Well, in order for us to have a true ellipse, we need to have 2 focus points. Well, the second focus point is right over here. So I'm going to label this guy as the other focus point. This C value is going to be the distance from the center of your ellipse out to your focus point. So that's that distance from the center out to your focus point. It very closely relates to the p-value that we had in parabolas. In parabolas, like we talked about last class, when you're going from a vertex out to your focus point or down to your directrix, that was that p-value, that distance. This C value is acting as that same thing in the sense that it's going from the center out to a focus point. There's no directrix here, so you don't need to worry about that. Let's look at the vertical ellipse. The vertical ellipse, as you notice, looks very similar. However, it's elongated now along the y-axis. Okay, so let's go through a few basic features. The H, let me use my pen. The H and K value is still representative of the center of your circle. Excuse me, not the circle. This is an ellipse. The center of your ellipse. We still have a minor axis, which is now vertically. And this minor axis is still representative of A. So I'm going to make this formula for the major axis 2 times A. And for the minor axis, this is now looking at the horizontal line here. It's the smaller side. So for my minor axis, we're going to represent that by 2 times B. And just like we did before, we had one focus point here and another right up here. So we have 2 focus points, so foci. The last thing I want to do is I want to see, okay, wait a minute. On the last question, we said when your a squared is under x squared, that tells you your graph is horizontal. If you look at where the a squared is now, the a squared is now under your y value, so the y minus k squared. So I'm going to make a little note that when your a squared is under the y squared term, your graph is going to be vertical. This will help you to remember. If you're looking for a vertical graph, it should be elongated along that y-axis. So it should be a very nice long graph. So those are the 2 things that we've talked about as far as the 2 different equations, how they relate, and how to determine which type of ellipse you're going to draw. Let's go ahead and look at the last 2 pieces down here. I mentioned this before. The C value is the distance from the center of your circle to your focus or foci point. So that distance that I have right here is going from the focus point or from the center out to your focus point. And that same distance can go from here to here. And that's the same thing on this graph as well, from the center to the focus, from the center to the focus. For both of those, notice that that C value, there wasn't anything that I said in the actual given equation above how to find it. So to find your C value, you're going to use this formula down here. And if you look at this formula like, hey, Miss Tapia, I remember this formula. Yeah, you should. It looks very similar to Pythagorean theorem, but it's a little different. The reason why it's a little different is because instead of it being added now, it's being subtracted. So whenever you're trying to find your C value, you have to use the a squared minus b squared formula to find your C. There is one last thing I want to mention before we move on to that last piece on this page. For your C value, that distance from the center to your foci, there's 2 things I want you to remember. This should always be inside of the ellipse, and it should be on the major axis. So if you look at both of the graphs that I have and the highlighting pieces that I've done, notice that they are on the major axis, they're on the longest side, and they're also inside of the ellipse. There's no points that are outside. So every graph that you create for me, you want to make sure that all of the items that you're labeling and identifying are representative of inside of that ellipse. You don't want anything to be outside of your ellipse. And then the last and almost important piece is that the a squared value is always larger. So on the 2 equations that we've talked about so far, I just kept saying, well, a squared if it's under the x squared, if a squared is under y squared, it'll tell you what type of graph it is. But how do you know what the a squared value is? Well, the a squared value is always going to be whatever is larger. So if you have a larger number under one fraction compared to the other, that's how you know you have an ellipse. I will mention, none of these should be the exact same, none of the same denominators. So let's go ahead and look at the next page and actually look at one problem. What does it look like when your a squared value is larger? Okay, so looking at our first question, we have x squared over 25 plus y squared over 4 is equal to 1. Okay, so let's identify first. What's the a squared value and what's the b squared value? Well, between both of those denominators, the bigger number is 25. The great thing about whatever's in your denominator, you don't have to re-square it. It's already been squared, which means that the b value, b squared, is going to be 4. Perfect. We did that. That means that the a squared value is under the x squared term because a squared is 25. So I'm going to make this note. A squared is under the x squared term. Well, since the a squared value is under the x squared term, that means that the graph is going to be horizontal. We just talked about that on the last page. Once you have this small piece of information written down, this is going to help you with identifying, okay, in your head, you should be thinking of a horizontal graph should be elongated along the x-axis. Okay, so this is the shape that my graph should be making. Let's identify the center of that graph. Well, if you think back to a circle, when you didn't have any value next to the next to the x or y in this form, you would write out your center as the origin, 0, 0. I know that my a squared value is 25, but what's the a? Well, if I want to find the a value, I'm going to need to square root both sides. There's methods to my madness, guys. There's a reason that I'm rewriting this. So let me rewrite it and then square root both sides. So a is going to equal 5. Technically, let me make this little note. Technically, it should be plus or minus 5. But since I'm talking about a distance, I'm just going to put positive 5. Technically, I would just put positive and negative 5. But since we're talking about a distance, I only want to see the a value as positive 5. And then for the b value, again, there's methods to my madness. I'm going to square root both sides. B is going to equal 2. Again, technically, especially since we square rooted both sides, it should be plus or minus 2. But since I'm talking about a distance, we're only going to make this a positive 2. With the information I have right now in pink, let's go ahead and graph this on my coordinate plane. So the first thing I'm going to graph is the center, which is the origin. I know the graph is going to be horizontal, so horizontal means that it should look something like this. Since a is the larger number, a is going to be 5 units, which means I need to go left and right 5 units because it needs to be longer. It needs to be elongated along the x-axis. 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5. And then for my b value, I'm going to go up and down 2 units. That's going to be along my minor axis. So up 2 and down 2. And then once you have those points, let's go ahead and create a nice looking ellipse around this. Make it draw it one more time. That's a little better. So that's my ellipse. From that ellipse, I need to actually find my c value. So for my c value, if you're like, wait, how do we find the c value again? It's very similar to Pythagorean theorem in the sense that you're going to use this formula. We're going to use c squared, We're going to use c squared equals a squared minus b squared. Remember how I said there were methods to my madness and I didn't square root this or this? The reason why I did that is because I knew I was going to need to find my c value. If you're going to find your c value, let's use the a squared that's already here. Remember, you don't need to re-square it. Minus b squared, which again, you don't need to re-square it. And then we can subtract. So c squared is going to equal 25 minus 4, which is going to be 21. And from here, I'll need to square root both sides. So my c is going to equal, technically plus or minus, but I'm talking about a distance, the square root of 21. Okay, so my c value is the square root of 21. You want to also make sure that you can potentially, if needed, simplify it. If I break up 21 into nothing but prime numbers, I have 7 and 3. 7 and 3 are literally prime. There's nothing else I can do. If I rewrote the square root of 7 times 3, can anything escape from this radical prison? No, nothing. So there's no point in me trying to simplify the square root of 21. That's it. That's all I can do. Only issue is, remember how we said c is the distance from the center of your ellipse out to the focus point? Yeah, I don't know exactly how far the square root of 21 is going to be going from this center out. I don't know how far that's going to be. So get your calculator out next to you and actually calculate, what is the square root of 21? Well, I've done it in my calculator. The square root of 21 is going to be approximately 4.58257. Okay, well that's not, I mean, it's helpful, but it's not going to give me too much by having all those numbers. Let me just make it 4.6. I'm only using that decimal 4.6 to give me the approximate point on my graph. The square root of 21 on your tests and quizzes, I want to see that listed as what your C value is, the distance from your center to your focus points. So over here, I'm going to go out 4.6 units, 1, 2, 3, 4.6. And then on the other side, 1, 2, 3, 4.6. So try to make those bigger. If you have a different color, make sure you use that so that way you can identify where those focus points are. Now here's the fun point. Remember how it said foci or foci, however you want to say it? I say foci. Remember how it says foci on the left side of this page? I need to know what are the coordinates for this and this. I need to know the coordinates. Well, don't give me 4.6 comma 0 because I want your answer, especially for your foci or foci, to be written as a coordinate. And I want it to be preferably as a simplified radical. So what we're going to do is I'm going to give you when you can't just look at the graph and give me the coordinate, I'll give you the coordinate in its general formula, and then you can simplify it from there. So for your foci, you're going to write this as h plus or minus c comma k. This equation that I just wrote, or this formula that I just wrote in green, is only specific to horizontal graphs. I'll say that again. This formula that I just wrote in green is only specific to horizontal graphs. If you have a vertical graph, this formula will not work. So with this h plus or minus c comma k, let me go over here to the side and let me figure out what it's going to look like. Okay, well remember, in your formula for the center, you have h comma k, so those are both 0, and the c value was the square root of 21. So I'm going to rewrite this as h plus or minus c comma k. Okay, well if you're adding and subtracting 0 to some radical, you really don't need that 0. So we can write this as, let's try that again, plus or minus the square root of 21 comma 0. This one you definitely do need to put that plus or minus square root of 21 because you're going to be writing 2 points for this. You're writing the positive square root of 21 right here and the negative square root of 21 right here. So positive square root of 21 comma 0, negative square root of 21 comma 0. If you want, you can rewrite this coordinate right up here, or if you like seeing both of them written out, you can. So write positive square root of 21 comma 0 in the first spot, and then negative square root of 21 comma 0 in the second. Something like that. For here on out though, I'm literally just going to be recopying this over here because doing this, these two coordinates are just too much work. And then the last piece is the minor and major axis. Well, remember on the last page, we said that the major and minor axis, if you pretty much just double what their A and B values are, you'll get that whole distance. If you don't believe me though, I know that my A value is 5. We found that earlier. If I double it, it should technically be 10 for that major axis, but you can always check it by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for my first number, I'm going to put 10 for my major axis. And for the minor axis, if you double 2, you'll get 4. 1, 2, 3, 4. And that's along your shorter side. If you don't like counting like I just did, you can just do 2 times A and 2 times B. So that's it. That's pretty much what we are going to be doing for graphing the rest of these. So take a second and look at it. Make sure you understand what we just did. And I want you to get a head start on example number 2 right below it. If you need to, pause the video, and I want to give you a quick minute head start. Try to do this without me. For question 2, I'm going to go through the same kind of process that I just did before. First thing that I want to do is label my a squared and my b squared. Okay, well, looking at both of those denominators, 16 is clearly bigger and 9 is smaller. So the larger number is 16. Remember, you do not need to square 16 again. It's already been squared. Since the a squared term, 16, is under, this time it's under the y squared term, that means the graph is going to be vertical, which means it should be elongated along the y-axis. With that in mind, I can use the h and k value to write out my center, just like we did for circles. I'm going to do the opposite of -2, which is positive, the opposite of +3, which is negative. Let me find my a and b value. So I'm going to rewrite this and square root. So a is going to equal 4, and b squared equals 9. When I square root, b is going to equal 3. From here, I can graph, at least start this off, +2, -3. My a value, okay, remember, a is under the y, which means it should be vertical, so the graph should look something like this. So take that second, like I just did, and think, okay, what graph am I drawing? So since a is going to be +4, we're going to go up and down 4 units. Let me double check that I counted correctly. 1, 2, 3, 4, 1, 2, 3, 4, and then left and right 3. 1, 2, 3, 1, 2, 3. Now let's go ahead and connect these dots to try to make the best ellipse that we can. From there, we're going to go ahead and find our C value. That C value will tell us the distance from the center out to your focus point, which I technically don't know right now. So to find your C value, we're going to do C squared equals A squared minus B squared. I purposely kept the original A squared and B squareds alone so we could use them now. So C squared is going to equal 16 minus 9. Well, if I subtract 16 minus 9, C squared is going to equal 7. And when you square root both sides, C will be equal to, not approximately, equal to the square root of 7. Technically, with the square root of 7, you really can't simplify it because it's prime. So I'm going to write out the square root of 7 as my C value. And I'm also going to approximate this C value as well, because when I approximate this, this will tell me how many units I need to go left and right or up and down on my graph, depending on how it's drawn. So the square root of 7 is about 2.64575. We're going to make this about 2.6 units. So on my graph, since it's vertical, from the center, I'm going to go up 2.6 units. And then down 2.6 units. Those are my 2 focus points in blue. Especially for this question, I don't really know what those coordinates are going to be, especially since this is a sketch. I don't know if this is supposed to be like 0.5 or 0.2. I really don't know. And it's negative, technically 0.5 or negative 0.2. Let's use the formula. So using the formula for foci, I'm going to write it now for its vertical graph. So remember, the first coordinate that we had was for the vertical graph. Let's try that again. The first formula I had up here is for your horizontal graph. So this little formula was for the horizontal one. This one I'm going to rewrite down here in green is for the vertical. That's what I was trying to say. H, comma, K plus or minus C. So with the space that I have, H, comma, K plus or minus C, my H value is 2, comma, K, which is -3 plus or minus 7. Well, especially for this one, there's really nothing else I can do for it. I mean, I could try to figure out plus or minus the square root of 7. There's really nothing else I can do for it. I mean, I could technically split this up where one is 2, comma, -3 plus the square root of 7, and then 2, -3 minus the square root of 7, but that's too much work. In this coordinate space, I'm going to just write this as 2, comma, 3 plus or minus the square root of 7. That's my focus point, or my foci points. The last thing I need is for my major and minor axes to be listed. So for my major axis, 2 times A, that's 2 times 4, which is 8. And then for my minor axis, that's 2 times B. And 2 times B is going to be 6. This is my graph. That's all I'm doing. So with the last graph that we haven't done yet, that's up to you if you choose to do it at a later time. I just want to go through the basics on how to graph these. let's go ahead and focus on the actual conic section portion. So for the conic section, I want you to keep in mind that we have been using this formula for the past 2 days when we've looked at parabolas parabolas and circles for those conic section formulas. We've been using the exact same formula. With circles, we saw that the a and b value were the same. And with parabolas, we saw that your a value or your b value was missing, which means that there was no x squared and there was no y squared. One of those was missing. For an ellipse now, an ellipse, you want to have your a and b to have the same sign, but you want the numbers to be different. So for an ellipse, you want the a and b sign to be the same, but they must have a different number. So I will make one little note. And if you're like, well, Ms. Tapia, what is the same sign? For these, they should always be positive. And if you're like, okay, well, Ms. Tapia, what about if they're negative? If they're negative, guys, read the part below it. If your a and b are negative, divide everything so that way it becomes positive. None of the equations we've graphed so far have been negative a and b. They've always been positive. So if we come to an issue where you have a negative a or b, we're just going to make it a positive. Our standard form that we're going to be creating are these two formulas. Remember, this one is where your x squared is having an a squared underneath it, which means it's a horizontal graph. This one is where your a squared is under your y squared term, which means it'll be a vertical graph. And just to kind of show you what the cross section looks like whenever you're actually cutting that cone, that conic, anytime you're going to get an ellipse is where you're going to be cutting it at an angle. For a circle, we just cut it pretty much parallel to the base of your cone. These two lines are pretty much parallel. That's how we created a circle. For an ellipse, you're really cutting it at an angle. So let's go ahead and look at the very first question. I'm going to try to go through the steps and through the question at the same time, so please pay attention. First thing we're going to do is we're going to rearrange the equation, move the constant to the other side, and leave a space to complete the square. So for this question here, I'm going to rearrange everything. 9x squared plus 36x this 36 needs to go to the other side. The way it's going to move to the other side is by being subtracted. So we're going to make this equal to negative 36. And just like we did before, whatever you do to one side, you have to do to the other. So both of these spaces. Okay, I have that first part done. Let me scroll back up. For step 2, okay, this is different. Factor out the leading coefficient from each of the squared terms. Okay, so in this technically trinomial that we're trying to create, we need to get rid of this 9. The way we're going to get rid of this 9 is we're going to factor out a 9 from here and here. It needs to be factored from both. Whenever we have a perfect square trinomial that we're trying to create and we have a leading coefficient that's other than 1, we did this the very first day when we looked at circles. You're going to need to get rid of it. So the way we're going to get rid of it is we're going to factor that out. So we're going to make this 9 parentheses x squared plus, 36 divided by 9 is 4. And I'm going to leave the same space. I'm not going to factor out a 9 from this missing term because I don't even know what the term is yet. I haven't completed the square. Let's do the same thing here. Okay, so for this term, I need to get rid of the 25 in front of y squared. When I do that, I need to divide this 150 by 25 as well. So we're going to make this plus 25. We're going to make this y squared minus, 150 divided by 25 is 6. And we're going to set that equal to negative 36. And when I have these two spaces that I had before, I now need to consider, we factored out a 25 and we factored out a 9. So when you do that, for each of those blanks, I'm going to do two additional things. Plus 9, whatever space is behind it, plus 25, whatever space is behind it. Because I want to make sure that you keep in mind that since you factored out something, you changed it from here to here, that you compensate for that change. And then the last thing is to actually complete the square. So let's complete the square for both of these equations. Scroll back up, and yes, complete the square. On one side, remember that whatever you do to one side of the equation, you have to do to the other. and make sure to multiply by the leading coefficient that you factored out. So that's that step that I just wrote right down here. Make sure that you multiply by that leading coefficient. All right, so let's see. For the first one, in order to complete the square, we're going to do 4 over 2, and we're going to square it. And if you're like, wait, where's the 4? We're doing b over 2 squared. Okay, well, 4 over 2 is 2, and 2 squared is 4. For the next one, for b over 2 squared, we're going to do negative 6 over 2 squared. Negative 6 over 2 is negative 3, and negative 3 squared is 9. Remember though, whatever you do to one side, you have to do the other. So we're going to add 4 here. Whoa, 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 not add. We're going to multiply 4 here and multiply 9 here. And if you're like, wait, why are we multiplying? Because it says, make sure you multiply by the leading coefficient that was factored out. All right, we're almost done. Step 4 at the top says to factor and combine your like terms. So let's go ahead and factor and combine our like terms. Factor this means that I'm going to rewrite this as a binomial with a positive 2. So this will be 9x plus 2 squared plus 25 y minus 3 squared is going to equal, okay, for this side over here, I need to combine my like terms, which means I need to multiply, add, all that good stuff. I'm going to make this negative 36 plus 9 times 4 is also 36. And 25 times 9, ugh, that's disgusting. That's probably going to be a large number. That's 225. Okay, well, it almost looks like the equation. I know that these two values are going to be able to cancel, and I have a 225 left over. So we're going to make this 9x plus 2 squared plus 25 y minus 3 squared is going to equal 225. I'm not quite done. If you look back on the first page over here, these should both be equaling 1. We talked about that the very first thing we noticed. Both of these were equaling 1, and we don't have really any kind of fraction. Sometimes you won't need to have denominators like this, but especially when your answer is not equal to 1, you're going to want it to equal 1. So the very last step is to divide everything and make the equation equal to 1. Well, in order to make this equation equal to 1, I need to divide the entire equation by 225. By doing that, I'll get equal 1. Only thing now is I need to simplify this and I need to simplify this to see what are the numbers going to be. Hopefully they simplify. So let's do that in my calculator. If I was to divide 225 by 9, that's going to give me 25. So I'm going to make this x plus 2 squared over 25 plus, I'm going to take 225 and divide it by 25. That's going to give me a 9. So y minus 3 squared over 9. This is my equation. It seems like it takes a while for it, but it's literally just going through the same steps and adding in literally 2 more pieces. The 2 more pieces are factoring out that common number that they have and then dividing everything by 225 at the end. So let's take this and graph it. Over here to the side, I'm going to rewrite the formula. So we had x plus 2 over 25, don't forget to square it, plus y minus 3 squared over 9, and we're setting it equal to 1. Before we try to identify anything else from here, is this going to be a horizontal or a vertical graph? Well, since the a squared is under the x squared term, that means it's going to be horizontal. The center for my graph is going to be h, comma k. And now I just need to find my a, b, and c value. So for my a squared is currently equal to 25. If I was to simplify that, I would just need to take the square root of 25, so a would just be 5. And then for my b squared is equal to 9. So if I wanted to just find my b value, that would just be 3. Let me graph what I have so far. -2, +3. Since this is horizontal, I'm going to go 5 units from left to right. and then up and down 3 units. Let's try this one more time. It's not going to look right. Oh, I'm keeping it. So that's our ellipse. Okay, let's find our C value. So for the C, we need to use our formula, and I'm going to give myself some space. So C squared is going to equal A squared minus B squared. Well, I labeled them at the top. Your A squared is 25, your B squared is 9. So this is C squared equals 25 minus 9. If I was to subtract 25 minus 9, that's going to give me 16. And when you take the square root of 16, C is going to equal 4. Oh, that's wonderful. I don't have to worry about having any radicals or worrying about simplifying. My C value is just 4. So from the center out, I'm going to go 4 units. So I'm going to go over 1, 2, 3, 4, and 1, 2, 3, 4. The best part about this is I don't need to use my formula, which is h plus or minus c comma k. Since this is horizontal, I can just literally look at these coordinates and see what is the coordinate. This goes over 2 units and up 1, 2, 3. So the first one is 2, 3 for my foci. And then for the other one, it's going to go over 1, 2, 3, 4, 5, 6, and up 1, 2, 3. So 6, 3. That's it. I don't have to worry about anything else. And then the last piece, even though I didn't want to have to do it, but I will anyway, let's find our major and minor axis. Our major axis is just going to be double 5, which is 10. And our minor axis is double 3, which is 6. That's everything I needed. Right now, I want you guys to start off and try number 5. Okay, for number 5, first thing we're going to do is we're going to rearrange everything. So I'm going to rewrite 4x squared plus 8x, leave a space, plus y squared minus 4y, leave a space, and then this positive 4 needs to move to the other side. So I'm going to make that negative 4, leave a space, leave a space. From here, I know that I need to factor out the leading coefficient for the x squared because I can't have anything in front of the x squared. If I look at the y one though, the leading coefficient is 1. So the best part about this question here for number 5 is I only need to factor out a 4 from one of the terms. I don't need to factor it from both. So down here, I'm going to factor out this 4, and that's going to leave in parentheses x squared plus 2x, leave a space, plus, the great part about the second one is it's literally just going to be the exact same thing. It's going to be y squared minus 4y, leave a space. And that's going to equal negative 4. I only need to rewrite for my first blank. I need to rewrite that 4 for just this one. So plus 4 times this blank. And then for this last blank over here, I don't need to multiply anything because I didn't factor anything out from the y. So I'm going to put plus this blank here. All right, let's go ahead and solve it. We're going to take the b over 2 and square it. So plus 1 times 1. Because remember, we're supposed to multiply on the right side of the equation. And then for my second blank, this is just like normal. So negative 4 over 2. That's going to give me negative 2 squared, which is positive 4. And this is plus 4. So from here, I'm going to go ahead and try to factor it and then simplify my combine like terms things if I need to. So in this x squared trinomial, I'm just going to simplify it to x plus 1 because that 1 is positive. So 4 times x plus 1 squared plus, for my second one here, I need to factor this. So I'm going to make this y minus 2 squared, and that's going to equal, let me take all of this and simplify. We're going to make this -4 plus 4 plus 4. Well, those two 4's cancel. That's my equation. But as you hopefully remember, I need this equation to equal 1. In order for this equation to equal 1, I need to divide everything by pretty much this last number. Whatever this number is, I want it to equal to 1. So we'll divide all of these by 4. For this first fraction, 4 divided by 4 is going to cancel. So that's just going to be x plus 1 squared plus, we're going to do y minus 2 squared over 4, and we're going to set that equal to 1. If you're like, Ms. Tapia, we messed up. There should be a fraction here. Well, we just kind of wrote that. I shouldn't have, but I did. We can put it over 1. That over 1 will help and will suffice enough. I will tell you though, on tests and quizzes, if I don't put this over 1, it's your responsibility to know that it should be over 1. So let's recopy this over here at the top. And after I recopy this, I want you to pause the video and I want you to try to graph this equation and give the formula for it. So give me all of the formulas that I asked for below and graph this out. Pause the video now and do it. Okay, so let's see what we got. So I made a note that we do have our a squared under x squared, which means it should be a vertical graph. I listed my center, I listed the a and b value, and I graphed out the center, a, b, and created the ellipse itself, so to show you that it would be vertical. Okay, so our next step is to figure out what c is. So I've kind of already done that as well. Our c value should be the square root of 3. So I'm going to write out the square root of 3, and I'm going to plot 1.7 units from the center out to my foci. So from the center, I'm going to go up 1.7 units, which we'll say is here, and down 1.7 units, which is here. When we're writing out our foci for this one, especially since this is a vertical graph, you're going to need to use the formula h, comma, k plus or minus c. So for that one, I'm going to write that out. I'll do it over here. H is -1, comma, k, which is 2, plus or minus c. These are my formulas that I would write right in here. So if you want to rewrite both of them, you can. I usually only use both of those blanks whenever I have ones that are nice, like the last question, where they're easy to find. But for this one, I'll just recopy it here. -1, comma, 2 plus or minus the square root of 3. And that plus or minus includes the value that's above and below the center point. For the major and minor axis, for the major axis, 2 times a is going to be 2 times 2, which is 4. And for your minor axis, which is 1, we're going to do 2 times 1, which is going to be 2. Be very careful with those because some of you guys might have recopied your a squared and b squared values. Remember, if you need to count on this ellipse, make sure you do so. All right, guys, you saw what I did before with just writing out my information here. Make sure that you actually try this question before I do. I will give you a hint. Is there anything missing here? Yes. If you notice that there's no x value, so there's just an x squared, that's what's missing here. So still follow the process, move this 16 to the other side, and then try to factor it the best you can. I will tell you, as you unpause this, I'm going to have all of the standard form work completed. So I want you to pause the video right now and try it. And it's done. Take a second and look at it. Make sure you, if you need to, pause the video, see what steps you might have messed up on, see what I did, compare it to what you should have done. We have all of this, and we're going to rewrite the standard form right over here. So we have x over 16, x squared over 16, plus y minus 4 squared over 20, and that's all equal to 1. Again, pause this video. I'm going to zoom out a bit so you can see almost everything. Pause this video, and I want you to try to figure out what is this graph going to look like and how is it going to be represented. So do that now. and let's see what we got. So first thing I want you to notice is that since the a squared was under y squared, we have a vertical graph. I also want you to notice that since your larger number is 20, when you take the square root of 20, you're not going to get a nice pretty number. So that's why I wrote it as a square root of 20, which technically equals 2 square root of 5. On tests and quizzes, I would just want to see the 2 square root of 5 as your simplified radical. I kept the square root of 20 there because I needed to graph this out, so I graphed it as approximately 4.5 units. If you're very careful, it would almost look like a circle, but it should be just elongated just enough along the y-axis to where it looks like an ellipse. For b squared, we have the square root of 16, so I got that to be 4. And for our c value, it was actually working out very nicely and gave me a c value of 2. With that c value of 2, that gave me my 2 foci points that I wrote in this pinkish orange color on your screen. The only thing that I haven't done yet is written my major and minor axis. My major axis is double this. So 2 square root of 5 plus 2 square root of 5 is going to give you 4 square root of 5. And then for my minor axis, that should just be 8. So whenever you're graphing these out, be careful. All of this is very similar to what we did with circles, but I will tell you, all of the information that we did, especially as far as simplifying all of the beginning part, if you don't know what to do, it will be very difficult in the future. So take time now, review the concepts to make sure you understand it.